In this video, we're going to look at how to write numbers in scientific notation.
Let's look at how to write numbers in scientific notation. There are two steps. The first is to move the decimal point so it's located to the right of the leading non-zero digit. So you're going to create the factor first. The second part is when you create the power of 10. You're going to count the number of places you move the decimal point. This indicates the exponent of the power of 10. So let's look at numbers that are greater than or equal to 10. We're going to move the decimal point to the left. And in this example, we have 8,600. We're going to put the decimal point between the 8 and the 6, creating a factor of 8.6, which is greater than or equal to 1, but less than 10. And then we're going to get the power of 10 that we need to multiply it by. Well, the decimal point was here after the last zero. And we ended up moving that decimal point 1, 2, 3 places to get the factor of 8.6. So we get 10 to the power of 3. Let's look at numbers between 0 and 1, or really small numbers. We're going to move the decimal point to the right. In point 0024, we're going to put the decimal between the 2 and the 4, creating the factor 2.4, which is greater than 1, but less than 10. And we're going to multiply it by a factor of 10, taking the decimal point from where it was located 1, 2, 3 places to the right. So it's going to be times the negative 3. Let's look at some examples. I have 1,650,000,000 that I'm going to turn into scientific notation. So the first thing I need to do is create the factor. So I'm going to put the decimal point between the 1 and the 6. So I've created a factor of 1.65. This factor is greater than or equal to 1, but less than 10. Now I'm going to multiply it by a factor of 10, or a power of 10. And the decimal point was originally after our last zero. And to get from that last zero to where we put our decimal point for scientific notation, we're going to count how many places we moved. And we moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. That's where we get the 10 to the power of 9. Written in scientific notation, it's 1.65 times 10 to the 9th. Now, let's look at a very small number. I'm going to put my decimal point here between the 2 and the 6. And that creates a factor of 2.68, which again is greater than or equal to 1, but less than 10. And now to find the power of 10, we're going to multiply it by. We're going to take where our decimal point was, and we're going to count how many places we need to get to where it ended up. So I'm going to count 1, 2, 3, 4, 5, 6 places. And because it went to the right, it's a negative 6. All right, let's change these numbers into scientific notation. First one, 50,000. I'm going to put the decimal point after the 5. So my factor is 5.0 times 10 to the power of. And my decimal point was located at the last zero, but it's been moved 1, 2, 3, 4 places to the left. So that's going to be times 10 to the power of 4. For 25 million, I'm going to put my decimal point between the 2 and the 5. So I have a factor of 2.5 times 10 to the power of. Put my decimal point at after the last zero, and I count 1, 2, 3, 4, 5, 6, 7. So I have 2.5 times 10 to the 7th power. For the next one, I'm going to put the decimal point after the 5. So I'm going to have a factor of 5.0 times 10 to the power of 1, 2, 3. And it's going to be negative 3 because we're going to the right. And for the very last one, I'm going to put the decimal point after the 5 and before the 0. So I'm going to have a factor of 5.06 times 10 to the power of 1, 2, 3, 4. And it's going to be negative 4 because we went to the right. All right, the next thing that we can do with scientific notation is to compare and order them. So when they have different powers of 10, this is actually the easiest thing to do. The larger power of 10 is the greatest number. So we have 6.55 times 10 to the 7th and 5.42 times 10 to the 8th. 10 to the power of 7 is less than 10 to the power of 8, and it doesn't matter what the factor is. So that means that this number, 6.55 times 10 to the power of 7, is smaller than 5.42 times 10 to the power of 8. So now what happens when they have the same power of 10? You're just going to compare the factors. You're going to ignore the powers of 10. So in this case, we'll drop the power of 10 and have 2.51 compared to 5.42. 2.51 is less than 5.42, so then 2.51 times 10 to the 8th is less than 5.42 times 10 to the 8th. And then the last thing you can do is order them. The one that was to the power of 7 was the smallest one. Then the one that had the factor of 2.51 was less than the one with the factor of 5.42. And now they're written in order from least to greatest. All right, let's look at an example of ordering these three numbers from least to greatest. So the first thing I do is I compare my powers of 10. And this one, 10 to the power of 5, this is the largest one because it has the greatest power of 10. So I'm going to come over here and put 2.04 times 10 to the power of 5 because that's the largest. Now the other two have the same power of 10. So that means I need to focus in on just the factors that they have. So we're going to compare 6.8 to 5.65. And 6.8 is greater than 5.65. So 6.8 times 10 to the 4th is greater than 5.65 times 10 to the 4th. So then the smallest number is this one, 5.65 times 10 to the power of 4. And then comes 6.8 times 10 to the power of 4, and we already had decided that 2.04 times 10 to the power of 5 was the largest.